We will discuss about the attenuation losses in optical fiber. Okay. Now, so in last class we discussed about the types of optical fiber. So step index optical fiber and graded index optical fiber we discussed. So in yes, so in that step index optical fiber, so based on the refractive index of the core and cladding medium, so we can divide here so two categories, that is the step index and graded index based on the modes of propagation. So we can divide it into single mode and multi mode. Okay. So here in case of step index as well as graded index also there are single mode and multi mode optical fibers are there. Okay, so step index is nothing but if you will take core and cladding, so throughout the core refractive index is constant, and so at the interface of core cladding, so that refractive index is suddenly changes like stepwise. That's why we can call it as step index. So in case of graded index, so that if you will take core refractive index, that core refractive index is not constant, it is varies from one place to another place. That means at the center of the core refractive index is maximum. If you're going towards to the core cladding interface, that refractive index is decreases and reaches to the cladding refractive index. Okay, this is in case of graded index fibers. Okay, so and transmission, how it will be transmitted we discussed. Okay, now so modes of propagation also we discussed. Now coming to the, we'll discuss about the attenuation in optical fiber. So attenuation is defined as a reduction in the signal strength. Okay, so whatever we are sending the signal, so what we are getting the output. So that means input signal, what is the difference between the strength of the input signal and output signal? So that is the loss. Okay, so that is the reduction. So that reduction of the signal strength is called as attenuation. So here signal strength or power. Generally we will take when it is transmitted through a optical fiber, what happen, so may chance to reduce the signal strength or power. Okay, so that is defined as the attenuation loss is gradually measured in terms of decibels. Okay, so which is logarithmic unit. So I think in already you did this experiment. So optical losses, so that is loss in optical fiber, so formula is equal to minus 10 into log P out by P in. Okay, so minus 10 into logarithm of P out by Pn. This is the optical power loss in decibels. Okay, so optical power loss in decibels. So here P out is the power emerging out of the fiber. P in is the power launched into the fiber. Okay, so because of the bending, so there is a losses will be there. That bending loss you calculated in the, so what is that, practical exams. So that is the optical bending losses. Okay, now so by using this formula you are calculated. So it's also depends on the length. Last for kilometer is equal to minus 10 by L into log of P out by P in. So this is the units for here is decibel per kilometer. L is the length of the optical fiber. Okay. Now there are two types of losses are there. So one is the transmission losses, another one is the distortion losses. So in bending losses, you are find out the distortion losses, not transmission losses. Okay. So you are calculated the distortion losses. Okay. Now coming to the transmission losses. So what is the transmission losses we will discuss here. So the mechanism of attenuation during the transmission, broadly classified into two categories. That means during the transmission of the light, so there are some losses will be there are some attenuation will be there. So those losses we are called as transmission losses. So those are mainly two types of transmission losses are there. So first one is the absorption losses and second one is the scattering losses. Absorption losses and scattering losses. Okay, so in case of attenuation, So attenuation is nothing but a loss of strength or power. Okay, loss of strength or power. In that there are two types of losses will be there. One is the transmission loss, another one is the distortion loss. Okay, first of all we will discuss about the transmission loss. In the transmission, while optical wave is traveling inside the optical fiber, so in that transmission there are some losses will be there. So those losses are absorption losses and scattering losses. Okay, so first of all, what is the absorption loss? We will discuss about that. Okay, so before going to the this absorption loss, I will discuss about the general topic. Okay, suppose see here. Okay, suppose I am taking any material, any type of material here. So any light is instant on here. Any light is instant on here means what happened? Some light is absorbed. Some light is absorbed. What is the reason for absorption? What is it? So in semiconductor we discussed. In semiconductor we discussed. Suppose so energy band gap, valency band, conduction band. Valency band, conduction band. There is a energy band gap will be there. Whenever suitable light is instant on it, so that light is absorbed by that material, and so that valency band electrons will goes to the conduction band. So because of that reason, what happened? So here semiconductor absorbs the energy. Absorbs the energy. So remaining materials also, suppose if you will take metals, ceramics, alloys, any materials. So every material absorbs the energy. Every material absorbs the light energy. Depends on the, so depends on their vibrations. Okay, suppose if you will take any material, in that material there are so many atoms will be there. Those atoms are vibrate with a certain frequency. Those atoms are vibrate with a certain frequency. Suppose I am taking one atom here, that atom is vibrating with certain frequency like this, and any direction it will vibrate in any direction. Okay, so whenever so suitable frequency of light, so this means so this is oscillating with the 10 hertz. Okay, same 10 hertz frequency is instant on here. So what happened? So it absorbs that energy. So that's suitable frequency. So if it is vibrating with 10 hertz means if 10 hertz light is incident on it, so what happened? The 10 hertz light is absorbed by the, so this atom, so these vibrations will be increases. Okay, because already we said that resonance process. So its frequency, its vibration, atoms vibration frequency and light frequency will be equal. So at that situation resonance will be occur. Resonance will be occur in that absorption peak. So absorption peak suddenly we will get so bump like this. Okay, so this is the resonance frequency of this atom. Okay, because so at this frequency what happened? So this atom's vibrations and so this what is that incident ray frequency, atoms frequency and incident ray frequencies matches. At that frequency what happened? Absorption will be takes place. Absorption will be takes place. Understood? So because of this process, if you will take any material will vibrate with certain frequency. If you will take any material in that atoms or molecules are vibrate with certain frequencies, either rotational frequency, vibrational frequency, or electrical frequency. So many, so that means so many vibrations and rotations will be there. Okay, so electrical vibration, rotational vibration, and so many like this will be there. So if any frequencies matches to those frequencies, what happen? Absorption will be takes place. Absorption will be takes place. So due to that reason, so light is absorbed by the materials. Light is absorbed by the material. Different materials having different absorption regions. You can search in Google also. Suppose, so what is the absorption range of iron? What is the absorption range of copper? So if you will search in Google, you can get the range of absorptions. Range of absorption by using this process. So by using this process you can so you can use the sensors also. Every material used as a one sensor based on this process, based on this absorption process. Okay, now coming to the, so we will discuss about the absorption loss in optical fiber. Generally optical fibers are made up of so either glass or plastic, material. So there are so many different types of glass materials are there. Okay, so different types of glass material having different absorption ranges. Okay, and if any water molecule will be present inside that material, so that water molecule also absorbs some radiation. Okay, so like that, so based on these all considerations, so there is a absorption loss will be there. See here, core material of fiber absorbs few wavelength as optical pulses or wavelength pass through it. Okay, so the absorption of light is caused by the following three different mechanisms. So these are, so ultraviolet absorption, infrared absorption, and ion resonance absorption. So that means, so different materials, I said that, so their vibrations and rotations will be different. So if it will be, it coincides with the, so whatever so that vibrations range is coincide with the ultraviolet frequency, so it absorbs the ultraviolet. So it rotational energy is coincide with the infrared absorption, it absorbs the infrared radiation. And ion resonance, that means ion will be excited. Okay, so when it absorbs the energy, it will goes to the excited, so that is the ion resonance. So absorption, so different process will be there. So because of these reasons, what happened, so these optical fiber absorbs some light, absorbs the some light. So because of that absorption, what happened, some light may losses, some light may losses inside the optical fiber only. Okay, now, so if you will take some example, so pure fused silica. Okay, so it absorbs the ultraviolet absorption around 0.14 micrometer. So result in, so ionization of valency electron into the conduction band. So because of this absorption, what happened? So valency electrons will goes to the conduction band. Okay, so that is in case of fused silica. Okay, next, absorption of infrared photon by atoms within the glass molecules results in increase of random mechanical vibrations, and hence heating will be takes place. Okay, so because here what happened here, so that glass absorbs the molecules, infrared molecules. So that means infrared photons. So because of that infrared absorptions, what happened, so molecules will be vibrate, molecules will be vibrate. So because of that vibrations, what happened, so heat will be produces, so heat energy will be produces, that those absorption peaks. So if you will take silicon, if you will take silicon, so that it will be absorbed at, so 3.2, 3.8 and 4.4 micrometer, so wavelength range, micrometer wavelength range. If you will take OH minus ions, OH minus ions, so that means if any liquid molecules will be, so yeah, so present in the material due to the trapping of water molecules. So while preparation of the material, so some cases water molecules are trapped inside the material. So because of that reason, what happened, so it absorbs a certain range of frequency, OH molecules. So OH minus small ions will absorb certain range of frequency. So that range of frequencies, so 0.95, so 1.25 and 1.39 micrometer. So micrometer, so which my molecules absorbs, so these energy peaks. Okay, now so here some drop is graph is given. So this is the energy, so potential energy. So in if you will take ultraviolet absorption means in this energy level. So if you will take infrared absorption means in this energy level. Okay, so this is the infrared absorption level. So here total loss is given, total loss is given. Okay, this is the scattering, due to the scattering of the light, so there is some losses will be there. So total loss graph will be like this, total loss graph will be like this. This is about the, so attenuation due to the what is that, absorption loss, absorption loss. Now we will discuss about the scattering losses. Scattering is another parameter for optical attenuation, such as losses in glass arises due to microscopic variation in material density, random variation in refractive index, and structural inhomogeneities or defects occur during the fiber manufacturing. Okay, so here scattering occur means, so scattering is nothing but already we know that scattering process. Suppose sunlight, if you will take this sunlight, so while entering into the sunlight, what happen, if any dust particle will be there on the on the direction of sun rays, what happened? That light is scattered by the those dust particles. Similarly, so in case of materials, so that light is traveling. So in case of optical fiber, light is traveling inside the optical fiber. In case of any impurities will be present. In case of any impurities will be present, due to those impurities, light will be scattered. Okay, so not only impurities. So if you will take any defects, so manufacturing defects are, so due to stress strain, also some defects will be present. So defects is nothing but any manufacturing defects, also other after working conditions, also some defects will be occur. Due to these effects, due to this effects also, sorry, defects also, scattering will be occur. And inhomogeneity in materials. So inhomogeneity means while preparing the material, so throughout the material that composition is not same. So some cases throughout the material that composition is different. So that is the manufacturing error. Due to that manufacturing error, what happened? Inhomogeneities will be takes place. Due to that inhomogeneity, structural inhomogeneity, what happened? So some scattering will be occur. So because of these so many reasons, scattering losses will be occur. Okay. These inhomogeneities act as a reflecting and refracting facts to the scatter of small portion of light through the core into the cladding, uh, contributing for the losses. Okay, so because of this distortion, so because of these law, what is that? Some impurities and inhomogeneities and defects. So what happens? Some light is scattered into the core region to cladding region. So that means total internal reflection not occur for some portion of light. So that's why that light having, so what is that? May chance to lose that light. Okay, so this is the one more reason for scattering. This type of scattering we also call it as Rayleigh scattering. So Rayleigh scattering. Okay, now next one is the distortion or bending losses. Okay, already we discussed this. So generally, so this is the core material. So inside the core material, what happen if, yeah, see here, okay, if light is traveling inside the core, what happened? So total internal reflection will be takes place. So if what happened if any bending will be present? In core. Okay, so see here, I will explain you. Okay, here total internal reflection will be takes place like this. Okay, light is traveling, but here angle will be changed. See here, so here angle will be, that instant angle will be changes. Means, so this angle is less than the critical angle, means what happened? There is some loss. So that means that light is enter into the cladding medium. If light is enter into the cladding medium, means so that will not come into the again into the core. It will not again come into the core. So due to that reason, what happened? So there is a loss of light. Some loss of light. Okay, some portion of the light will be, so will may chance to get the loss due to the bending. Okay, these losses we will call it as distortion losses. Now we will discuss about the applications of the optical fibers. We will discuss here. So there are so many applications will be there. So first of all, we will discuss about the in communication system. What are the applications in communication system? Okay, so first of all, an efficient optical fiber communication system requires high information carrying capacity, such as voice signals, video signals over a long distance with a minimum number of repeaters. Okay, it essentially consists of the following parts. So that means, so while optical fiber is traveling inside the optical fiber, so that means that this optical fiber may transmit the light into voice signals, video signals over a long distances. So first of all, these signals we have to convert into first, so optical signals. Okay, so first of all, so these voice signals and video signals are whatever it will be there, whatever we want to transmit. So first of all, we have to convert into so that optical signals, because in case of optical fibers, only optical signals are transmitted. So that's why whatever the signals will be there, those signals we have to convert it into the optical signals. So for that, so there is some essential parts is required. Essential parts are required. Those parts are encoder, transmitter, waveguide, receiver, decoder. Okay, so we'll discuss about these parts now. So encoder, and what is the use of encoder? It converts the electrical signal corresponding to the analog information such as voice, figures, objects, etc. into the binary data. So whatever, so it will be there. So whatever we want to transmit, so here voice signals or figures or objects or videos or anything. So first of all, we have to convert into binary data. Okay, so that binary data, this binary data comes out in the form of stream of electrical pulses. Okay, these binary data, first of all we have to convert into so binary data. That binary data again we have to convert it into electrical pulses. Electrical pulses means already we discussed about the, so binary data means yeah, so I will explain you through graph. Yeah, how it will be transmitted as a, yeah, so when it will be minimum, so when it will be minimum, that is 0. So applied voltage is minimum means that is 0. So applied voltage high means it will be 1. So 0 1 binary data is nothing but 0 1 so like this. So that signal, so sended signal, electrical signals will be like this. So that binary signals are converted into electrical signal. Okay, so like this. So that is encoder will be uses, encoder will be uses to convert the, so this voice signals, figures, objects into binary data. Next, transmitter in mainly consists of the drive circuit and light source. So drive circuit supplies the electrical pulses to the light source from the encoder. So here, so this is the encoder. So through encoder, so that those these electrical pulses supplies to the drive circuit. So that drive circuit converts that electrical pulses into so light source. Okay, so that means here this encoder is connected to the drive circuit. So that encoder supplies the electrical pulses. That electrical pulses here converted into light source. Okay, so how to convert that light source means, so like by using LED. So LED are diode lasers. LED are diode lasers used as a light source here. Okay, so if you supply the signals, so if you supply the electrical signals to the these LED or diode lasers, so it converts that electrical signals into optical signals. So these LED and diode lasers are so converted into the those electrical signals into optical signals. These optical signals are injected into the waveguide. Okay, so now first of all encoder, so through encoder, so the first encoder transmits the, so these voice signals, figures, whatever it will be data, so that will convert it into binary data. That binary data is converted so converted into electrical signals, and those electrical signals, so electrical signals supplies to the so through drive circuit it's connected to the, so these optical sources. What are the optical sources here? LED and diode. So diode lasers, LED and diode lasers. So these optical sources converts the, so these electrical signals into optical signals. So these optical signals are injected into the waveguide. These optical signals are injected into the waveguide. So what is the use of waveguide? It carries the information through the desired distance, okay, in the form of optical signal. So how much distance we want to transmit? So this optical waveguide is nothing but optical fiber only. Here it carries the information through the desired distance. Okay, so in the form of optical signals, so after one is the receiver. So receiver, it converts the it it consists of photo detector, so amplifier, signal resistor. So photo detector, already we discussed about the photo detector also in third unit, optoelectronics unit. So this photo detector detects the, so these are optical signals and it converts into the electrical signals. So that photo detector so detects the optical signal and it converts into again electrical signals and it's connected into the amplifier, so that amplifier amplifies the those electrical signal, and so finally so signal receiver receives the signals, and what that signal receiver displays the, so whatever it will be there, so it picture will be there, it display the picture, so whatever it will be there. So your photo detector amplifier signal receiver is given. So finally so detector finally signals will be decoded and sent in the original form. So this detector decode the signal, decode the those electrical signal so received from the signal restorer. Okay, signal restorer. Okay, here black diagram is given, see here. So this is the electrical signals, so that electrical signal, so first of all pictures whatever it will be there, that is converted into electrical signals. So those electrical signals through encoder, so this electrical signal is converted into the drive source, so that that drive source supplies the, so these electrical signals to the light source. This light source converts the electrical signals into optical signals. So those optical signals transmit through the waveguide, and photo detector detects the this waveguide, and this photo detector converts the, so this into electrical signals. So those electrical signals, by using amplifier we can amplify the, so these electrical signals, and a decoder decoder decodes the these electrical signals into original form. This is the black diagram for what is that, optical fiber in communication system. Optical fiber in communication system. Next one is the, so optical fiber in sensors, how it will works in a sensors. Okay, now sensors are devices used to measure or monitor quantities such as displacement, pressure, temperature, flow rate, liquid level, chemical composition, etc. The measurement techniques developed using the fibers are more sensitive and reliable. So based on these parameter, okay, so what is that? So displacement, pressure, temperature, flow rate, and liquid level, so chemical composition, based on these parameters sensors will work. Okay, so in that sensors, so generally optical fibers, if you use the optical fiber means, so that will become more sensitive and reliable. Okay, so it will be used as a smoke detectors, and population detector can be made from the fibers. So these smoke detectors as well as population detectors also we can made, so by using fibers. Okay, the high sensitivity of the uh, fiber to external influences like phase sensitivity, micro bending losses, and modal noise is utilized to develop the new sensors. So by using, so already we discussed about the losses, attenuation losses in optical fiber. So based on those phenomena, based on those attenuation losses, so these sensors will be works. Okay, so because in between, is there any problem will be there? So suppose gas will be there, suppose we say oxygen gas will be there. Oxygen gas absorbs a particular wavelength, so particular wavelength of the radiation. So that's why, so if that what is that particular wavelength is misses, so that particular wavelength is lost here. So that means we can set that, so inside that optical fiber there is a oxygen gas will be there, suppose CO2 gas, HCl gas, like that gas sensors will works. Okay, so like temperature also, if temperature will be increases, if temperature will be increases means, so those absorption properties will be changes. Suppose if material, so we are taking silica material, silica, so silica glasses absorbed particular wavelength at room temperature. If you increase the temperature, what happen? That absorption range will be changes. That absorption range will be changes. So based on this, if temperature will be more, we can detect that, because so that absorption range will be changes because of the temperature. Also, what happen? So that absorption peaks will be different. Absorption peak will be different. Depends on these conditions. So either pressure also. So because of sometimes, based on the pressure, suppose if you take some gas, so that gas will be without pressure it absorbs some wavelength. If you apply the some pressure, what happen? It absorbs the another wavelength. So based on these conditions, we can prepare number of sensors. Every material we can use as a one type of sensors. Already I said that, because every material will absorb the particular wavelength. Okay, so based on these phenomena, we can use these optical fibers used as a sensors. That means, so in different sensors, their construction will be different. Okay, based on those constructions, we'll discuss about that. There are two types of sensors will be there: intrinsic or active sensor, extrinsic or passive sensors. Okay, so we'll discuss about those intrinsic and extrinsic sensors. So intrinsic sensors are also called as active sensors. In active sensors, the quantity to measured acts directly on the fiber itself. Okay, so fiber itself act as a uh, transducing element and modifies the light passing through it. Okay, inside the fiber. So that means the sensor used as a uh, active sensors is nothing but directly the sensor will act as a that optical fiber will act as a sensor. Optical fiber will act as a sensor. Okay, how it will be means, so without, there is no any other material, in between the optical fibers. Only optical fiber will act as a sensor here, based on the modifications occurring in the fiber. Already I said that. So modifications, if you increase the temperature means, so there is some modifications will be change in the optical fiber. So if you change the chemical composition inside the optical fiber means, so there is changes. So due to those changes inside the optical fiber, it will be act as a sensor. Okay, so intensity modulated sensor. So that's why what happened here. So because of some reasons, so intensity of light will be changes. So if intensity of light will be changes means, those sensors we will call it as intensity modulated sensors. So phase modulated sensors means, what happened now, we will place optical fiber, so inside certain any other material. What happened, suppose any pressure will be there means, any forces will be there means, so may chance to bend the optical fiber, due to that pressure. So depends on that bending also, some losses will be there, some phase change will be there. Okay, so that phase modulated sensors, if any phase change will be there inside the optical fiber. Okay, so in that output, if any phase changes will be there, so that will be act as a phase modulated sensors. Okay, now polarization modulated sensors. Polarization is nothing but some optical fibers absorb certain direction of the light. It allows only particular direction. Some materials allows the only particular direction, remaining all vibrations will be, it absorbs. Okay, so that process we will call it as polarization. So first of all, I will explain the what is the polarization. Generally, if you will take light, so any light source, that will be vibrate in all directions. So horizontal direction, vertical direction. Okay, so like this direction also it will vibrates. So light will be vibrates in all directions. So, but some materials allows that vibration in a particular direction. Remaining all directions will be absorbed by that material. Okay, so that's why after after passing the light, after passing light into this material, only particular vibrations will be emitting. So it will vibrate with only particular vibration. Remaining vibrations are all are absorbed. This process we will call it as polarization. Only here horizontal vibrations will be present. Okay, remaining all vibrations are absorbed by this material. That process we will call it as polarization. So because of the polarization modulated sensors also, so because of the polarization process also sensor will works. Those sensors we will call it as polarization modulated sensors. And wavelength modulated sensors. Wavelength modulated sensors means here suppose we are sending input is some wavelength, so output will be different wavelength, because and otherwise there is some loss of wavelength. So because of this process what happened, so output wavelength will be changes, output light wavelength will be changes. So that's process we will call it as wavelength modulated sensors. Wavelength based on the wavelength. So here some sensors will work. Those sensors we will call it as wavelength modulated sensors. These are all are the intrinsic sensors. Now extrinsic are passive sensors. In that passive sensors, the quantity to be measured acts directly onto the transmitting material which modifies the light. So how it will be means, so there is a one optical fiber will be there. Okay, so there is a one optical fiber will be there. So that by using this optical fiber, what happen, we are sending some optical signals into the any material. Okay, so this is another material, and so this is the received another optical fiber. This is the another optical fiber. Another optical fiber receives those signals. Another optical fiber, so the transmitted light receives the transmitted light. So in the transmitted light, so some wavelength may loss. Okay, so due to the so many reasons, so some wavelength will be lost. Otherwise in between there is a gas. So in between the two optical fibers, so in between two optical fibers there is a some any other material, any other gas or anything will be there. So these type of sensors we will call it as extrinsic sensor or passive sensors. Passive sensors. Okay, so because of these modification, so because of this external source, there is a modification of the output. There is a modification of the output. These type of sensors we will call it as extrinsic sensors. Okay, yeah. Now coming to the what is the time? Yeah, time up here. So this is enough for you. So no need remaining. So this is a medical endoscopy. Medical endoscopy also this is required. How it will be used in a medical endoscopy. So so we can send directly optical fibers into the our stomach. Okay. So in that endoscopy techniques, so it requires 1,000 fibers. So 1,000 fibers they can send. See here. So this is the optical fibers directly they send into the our stomach. So they examine the, so whatever defects will be there, anything will be there in our stomach, so they absorbed inside. So this is the endoscopy process. Yeah, there are some problems will be there, so those problems are not required. So this is about the so applications of optical fibers. Okay, if you have any doubts on this you can ask. So I will take the attendance now. Yeah. So if you have any doubts, you can ask. Otherwise, you can leave from the session.